All right, we need to find the domain of f of x, g of x, f of g of x, and g of f of x. So I'm going to do this by considering the restrictions on all of these. Okay, so first thing I'm going to do is I'm going to think about the restrictions on f of x, which f of x is the square root of x plus 3. And the main thing is that anytime you're taking a square root, whatever's underneath the root sign needs to be greater than or equal to 0. So x plus 3 is greater than or equal to 0. Subtract 3 from both sides, and we get the domain of f of x is greater than or equal to -3. Okay, now looking at g of x, which is x squared plus 4, you can square any number. I can square a negative number, a positive number, or 0. So because of that, the domain of g of x is all real numbers. There are no restrictions. So as soon as I know there's no restrictions on g of x, the domain has to be all real numbers. Okay, looking at the domain of f of g of x, which is the square root of x squared plus 7. So what basically I'm going to consider as a restriction is that x squared plus 7 has to be greater than or equal to 0. But x squared plus 7 has to be greater than or equal to 0. It never can be anything but, because when you square a number, it becomes positive unless it's 0. 0 squared is 0, but I'm still adding 7 to it. So when you add 7 to 0, you get 7. So no matter what, I'm either taking a positive number and adding 7, or it's 0 and adding 7. It's definitely going to be bigger than 0, no matter what. X squared plus 7 has to be greater than or equal to 7, no matter what. So of course it's greater than or equal to 0. This means that the domain of f of g of x is going to be all real numbers, because even though there is a restriction that it has to be greater than 0, it is greater than 0, no matter what. So the domain's all real numbers. And now on to the tricky one, g of f of x, which on the surface, it just equals x plus 7, which normally we'd think has no restrictions. You can add 7 to absolutely any number. But this is the problem. When dealing with composite functions, it's actually an order to it. You're putting this into f first and then into g. So the domain on f matters. I can't put a number smaller than -3 into the f function and get an answer. Say you try to put an f of -4. -4 plus 3 is -1. The square root of -1 does not exist. Then I got nothing to stick into g. So even though g of f of x is a composite function, simplifies to something without any restrictions, you have to go back to the original functions no matter what and consider the restrictions. So because there's a restriction on f of x, that x is greater than or equal to -3, and we put it into f of x first, you have to consider that for the domain of g of f of x.